Hi folks, welcome back. We are talking today about solving one and two-step equations. But before we get into solving equations, we need to remember what is the difference between an algebraic expression and an algebraic equation. Well, the key word there is actually equation. When we are working with an algebraic equation, you will always have an equal sign. One side is equal to the other side, and we're able to solve these for the variables. But if we're just given an algebraic expression, there's no equal sign. We might be able to simplify the expression using what we learned yesterday about combining like terms or the distributive property, but we can't solve for our variable because it's not equal to anything. So today we're working on the solving part. You will be able to solve equations using your knowledge of inverse operations to solve one and two-step equations and show your work. That is probably the most important piece in math in general, and especially when you're doing video lessons, to show all of your work, or else your sub will not give you the correct papers. So, first thing I want you guys to do is write down this objective in your notes right at the top so that you know what your goal is for today. Go ahead and pause the video so that you can take some time to do that. All right, so now let's move on. So the main goal for solving equations is where we need to start. We need to know what we're doing here. You might remember this from last year, but if you don't, our main goal is to isolate the variable. Well, what does that mean, to isolate something? Hopefully this picture might be able to help you. That is SpongeBob's little island there, and that island is actually in isolation. So that should help you understand what that word means, but it means it's alone. It's by itself. So right underneath where you wrote down your objective, I want you to write what the main goal for solving equations is. So write down main goal for solving equations, and then put a little semicolon, that it's to isolate the variable. And in order to isolate our variable, we follow our golden rule. So right underneath where you put your main goal, I want you to write down this golden rule. Whatever you do on one side of that equation, you always do to the other side of the equation, right? We want both sides to be equivalent expressions, and if we change one side without changing the other side, it's unbalanced. It's not equal anymore. They're not equivalent statements. So go ahead and write down that golden rule. You can pause it while you do that. So let's get into thinking about solving these equations. So we're first starting with one-step equations, adding and subtracting. I want to remember, in order to solve these, my inverse operations. So the first thing I'm going to do is take a look what operation is taking place here. So first step, write down your equation, m minus 11 equals negative 19. What operation is taking place? Well, I see it's subtraction, and I can even highlight it here. I see it's a subtraction problem, so now I have to think, what is my inverse operation for subtraction? Addition. So to solve this, sometimes people put a line down the middle so they know which side is which. You would add 11 on both sides, since that's my inverse operation. So that means my 11s are canceled out. I'm just left with m is equal to negative 19 plus 11 is going to leave me with negative 8. So m equals negative 8. And we should always get in the habit of checking our answers. So if m equals negative 8, that means if I plug it back in, negative 8 minus 11, does that equal negative 19? Yes. So we know we got this correct. Moving on down then, write down number 2, x plus 2 equals 11. I'm going to draw my line down the middle, and I also see that this is an addition problem. So thinking of my inverse operation, I'm going to subtract 2 on both sides. So then my 2's cancel out. I'm left with x equals 1 plus negative 2, or 1 minus 2. that's going to be equal to -1. Plugging that back in, does -1 plus 2 equal 1? Yes, so we know that we got that correct. Make sure you have everything on this screen written down in your notes. And let's move on to a couple more problems here. So now we have multiplying and dividing. So take a minute, write down number 1. So we have -2 equals p over 9, or p divided by 9. So I got to first think about what is my inverse operation here. If I'm dividing, my inverse is going to be multiplying. So I'm going to multiply both sides by 9. So then my 9's would cancel out there, and I'm just left on one side with p equals 9 times -2 is -18. Oh, my pen doesn't want to work here. -18. That's an 8, I promise. So we can plug that back in just to make sure we got it correct. Does -2 equal -18 over 9? Yes. So we know we got that correct. Last problem we're going to do together here. I see I have 150 equals 10n. Well, what is my inverse operation of multiplying? Division. So I'm going to divide by 10 to get n equals 15. Plug that back in. Does 150 equal 10 times 15? Yeah. Nice. Okay. So now take a minute, pause this video so that you can go through these problems. Okay, so you should have gotten x equals 6, x equals -7, x equals 17, and x equals -12. Okay. Next up, we have two-step equations. So when we talk about two-step equations, they're a little bit more challenging than just solving one-step equations, right? There's two operations happening on here. So really, if I'm going to go through and solve a two-step equation, I'm going to work in reverse PEMDAS, or reverse order of operations. So I would want to undo any I would want to undo any addition and subtraction first. So I see off to the side here in my equation x over 2 minus 10 equals -5 that I do have addition or subtraction that I can get rid of first. So I'm going to draw my line just to help me see. If I'm subtracting 10, what's the inverse operation? Addition. So I'm going to add 10 on both sides. Don't forget that golden rule. My 10s are canceled out, so I have x over 2 equals -5 plus 10 should leave me with 5. So now I'm down to a one-step equation. I'd now want to undo any multiplication or division. Since I'm dividing, I use my inverse operations of multiplication to multiply both sides by 2 to get x equals 10. And always we want to make sure that we check our answers. So 10 over 2 minus 10, does that equal -5? Well, if I simplify, 10 divided by 2 is 5 minus 10, which gives me -5. Yep, those sides are both equal. Now that's a silly story to remember. If it gets confusing thinking of it as reverse order of operations, then here's a fun story that you can remember. So imagine that you're having a sleepover and your mom lets you invite 2 friends over. So you invite your very, very best friend and then your okay friend. You guys are hanging out, you're getting rowdy down in the basement, and then your mom comes down and she's like, hey, you guys are too loud, you gotta send somebody home. Well, are you gonna send home your really very best friend or your kind of friend? Most likely you're gonna send home your kind of friend. So that's the number that's away from our variable. Let me clear this off here. So this is your kind of friend, and you, my friend, are the variable. So that kind of friend is the farthest away from the variable. That's going to be the one you get rid of first. Then, as you're going about your night with your mom, you're getting rowdy again, and she's like, hey, you got to send your other friend home. Your other friend being your very, very best friend, the one that you would never want to lose, right here. So that's the second one that you always get rid of. So you want to get rid of the one that's closest to the variable or closest to you first. Hopefully that'll help you remember it, or you can just remember to work in reverse order of operations. So just a few questions here. Thinking, what's our variable when we're solving two-step equations? What operations are happening to the variable? How do I undo them? And lastly, which one do I get rid of first? So if you think through those 4 questions with each multi-step equation, that will help you to go through and solve them. So go ahead and write down each of those 4 questions. Make sure they are numbered in your notes so that you have them to refer to later. And pause the video when you do that. Okay, so let's use these to try another problem. So write this one down in your notes. 18 equals 3p plus 10. So if I'm working in reverse order of operations, first thing I'm going to get rid of is any addition or subtraction. So I'm going to draw my line first of all, down the middle. And then I see I have multiplication happening and I have addition. So I want to get rid of my addition first. Inverse operation of addition would be subtraction, so I'm going to subtract 10 on both sides. So then my 10s cancel out, 18 minus 10 should leave me with 8 equals 3p. So I'm done with addition and subtraction. Then I see I still have multiplication left over. So the last thing I want to do is divide, my inverse operation of multiplication. Divide both sides by 3. My 3's cancel out on one side, so I'm left with p. On the other side, I have 8 divided by 3. Well, does 3 go into 8? No. So actually, I could simplify this fraction, right? I could simplify 8 over 3 to be 2 and 2/3. But as you get into higher levels of math, you would also be able to leave your fraction as an improper fraction. So I would accept both of those answers, 8 over 3 or 2 and 2/3. I don't want you guys writing these as decimals because that would be a repeating decimal and you can't really write that out. So how about you guys give this one a try? All right, I think that might have been enough time, so I'm going to first draw my line. First thing I'm going to get rid of is any addition or subtraction. I see I have addition, so I'm going to subtract 12 on both sides. My 12's cancel. I have 8x on the right side, and then on the other side, what do I have? 12 minus 12. Oh, my 12's cancel over there too. I'm left with 0. This one you might be able to solve right here. What times 8 equals 0? You might be able to tell me. Or you can divide both sides by 8. 8's cancel, so I'm left with x equals 0 divided by 8 is 0. Plugging that back in, we can check it. I realized I forgot to check that last one, or the last couple. Sorry about that. We should get in the habit of it. Even Miss Weldy needs to get in the habit of it. So if I solve that side, 8 times 0 is 0 plus 12. Simplify that to just get 12. Both sides are equal. So I know I got that problem correct. Okay. Give this one a shot. Pause the video real quick. All right, let's go through it. I'm going to draw my line first. I'm going to get rid of this addition problem first. So I see I have 11 plus 12x equals 15. I want to get rid of addition first, so I'm going to subtract 11, both sides. 11's cancel, so I have 12x equals 15 minus 11, leaves me with 4. And lastly, divide both sides by 12. Hopefully you realize that that would give you a fraction, and you can simplify that fraction. Divide both terms, or both numbers, by 3. Oh, I'm sorry. No, don't do it by 3. Divide them by 4, how about? And then you get 1 over 3, or 1/3. If I plug that back in, I get 11 plus 12 times 1/3 equals 15. And if I go through and simplify that left-hand side, I have 11 plus 4, which simplifies to 15, which checks out. Okay, so that was the last example problem that we were going to do. So you can go show the sub your notes, make sure they're good notes and you're including everything, or else the sub will not give you your assignment.